All right, so we are getting back to it today, and we are starting with solving exponential equations. So basically what this says is that if you have some base, the base is the number that's raised to an exponent, right? So if you have some number, some base that's equal to another base, then their exponents are equal, okay? So if you had 2 raised to the power of x is equal to 2 raised to the power of 5, then those powers, those exponents have to be equal, right? In order for 2 raised to some power to equal 2 raised to the power of 5, well, if they're going to be equal, then x has to also be 5, so that 2 to the 5th is equal to 2 to the 5th, right? So x would have to be 5. So basically what that means is if you have the same base, okay, then your exponents are equal. So you can just kind of drop the base and focus on the exponents if you need to solve for x. Okay, so like 2x equals 2 to the 5th, x equals 5, right? We have the same base, 3 to the power of 4x equals 3 to the power of 8. So we can drop our base and focus on 4x is equal to 8, right? The exponents have to be equal because the base is equal. And so 4x equals 8, and we would just solve for x. So we would divide both sides by 4 and get that x equals 2. All right, so same thing here. We have 5 raised to the power of 2x and 5 raised to x plus 1. So I can drop my base, right, because the bases are the same. So I would have 2x equals x plus 1. And then I'm going to solve for x. So I need to get my x's on the same side. So I'd subtract 1x from both sides to cancel it out over here on the right side. 2x minus 1x is just 1x. And then bring down your equals positive 1. So x equals 1. Of course, you can always check your answers. So if you took this 1 and plugged it back in, 2 times 1 is 2. And then you put it here, 1 plus 1 is 2. So we get 5 to the second power for both. Okay. This third one, we have the same base, but on this second one, I don't actually have an exponent, right? Wrong. If you don't see one, there's always the power of 1 there. Okay, so even though we didn't have anything there, there's always an exponent of 1, okay? Which means I would have 2x minus 5 equals 1. And I would solve for x. So to get x by itself, I'm going to need to add 5 to both sides. So I get 2x equals 6. Divide both sides by 2. And we get that x equals 3. Oh, there we go, sorry, x equals 3. Last example, bases are the same, so we can set our exponents equal to each other. So we're gonna have 3x plus 5 equal to x plus 1. So I'm gonna get my x's on the same side, so I'd subtract 1x away right here to cancel it out on the right. And I have 2x plus 5 equals 1. Now it's just like we had up here, but instead of minus 5, we have plus 5. So to cancel out a plus 5, I'm going to subtract 5 on both sides. So I get 2x equals 1 minus 5 is a negative 4. And then I'm going to rewrite that over here where I have more room. 2x equals a negative 4. Divide both sides by 2. And we get x equals a negative 2. Alright, to solve exponential equations, you must first rewrite each side of the equation using the same base. Okay? So, for example, if I had 3 to the power of x equaled 9, well, you know x has to be what? A 2, right? Well, what they're saying, because 3 squared would equal 9, what they're saying is if you rewrote this one instead, if you rewrote it to be 3x equals, and then we changed 9 to be 3 squared, right? Then we would see that x equals 2, because now we have the same base. So down here, we're going to see what we could rewrite 256 as to have the same base as 4, okay? All right, so what I'm going to want to do is see what 4 would need to be raised to be 256. So we know it's not 4 squared, that's going to be 16. 4 to the third power is 64. 4 to the fourth power is 256, okay? So I'm going to say 4 to the power x equals 4 to the power of 4. And that would mean x equals 4. Okay? So the reason we do that is because sometimes they're different. Actually, I want to do number 3 first. Right? So we just looked at one earlier, how we could rewrite 9 to have a base of 3, right? Because 9 is the same thing as 3 squared. So we can rewrite 9 to have a base of 3 by saying 3 squared, and then you still need to bring down that 2x, would equal 3 raised to x minus 6. Okay, so all I did, nothing changed on the right side. 2x is still my exponent. All I did was change 9 to be 3 squared. Okay? So that means now I have power to power, so I need to multiply these. So I get 3 to the 2 times 2x would be 4x equals 3 to the x minus 6. Now they have the same base, right? So now we can set our exponents equal. Up here we didn't have the same base, so I couldn't set those exponents equal. Now we can set them equal. So I'm going to have 4x equals x minus 6 minus 1x on both sides. Gives me 3x equals negative 6. Divide both sides by 3. And we get that x equals a negative 2. Okay. All right, now we'll look at example 2 up here. So is there any way to rewrite 8 to have a base of 4? We know 4 times 2 is, 4 times 2 would be 8, right? But that doesn't mean I can rewrite it to have a base of 8. A base of 4. So what I mean is there anything I can raise 4 to equal 8? 4 squared is 16. That's already bigger than 8, right? So their common base is not going to be 4. Their common base is going to be 2, because 2 squared is 4, and 2 to the third power is 8. Okay, so 2 is going to be the common base. So we're actually going to rewrite both of these. Okay, so I'm going to rewrite 4 to be a 2 squared, and then I'm going to rewrite 8 to be a 2 cubed. Okay, so I'm going to say 2 squared raised to the power of 3x equals 2 cubed raised to the power of x plus 1. Okay, so now we just need to multiply our exponents together, because this is a power raised to another power. So 2 times 3x would give us 2 raised to the power of 6x. And then 3 times x plus 1 means we're multiplying 3 by both of these. So we would get 2 raised to 3 times x is 3x, and 3 times 1 is a plus 3. Same base, so we can basically drop our bases and just focus on the exponents. So we would say 6x equals 3x plus 3. Okay, so I'm going to subtract 3x to get my x's on the same side. And now I have 3x equals 3. Divide both sides by 3. And we get 3 divided by 3 is 1, so we get x equals 1. All right, so notice we have a fraction. So this is where you want to remember that the way to make a number go from the bottom to the top or top to bottom, either way, if you want a number to flip from one side of your fraction to the other side, you have to deal with negative exponents. Okay, so for example, if I had 3 to negative 1, power of negative 1, then that's going to give me 1/3. Okay, so my number switched from the top to the bottom, and then it went from a negative exponent to a positive, or like 3 to negative 2 would be 1/3 squared, right? 2 went from negative to positive, but your 3 switched from the top to the bottom, right? So same here. I want to rewrite 1/3 to be 3 to the negative 1, okay? Because I want these to have the same base. Well, 3 can have, or 27 can have a base of 3, but we first need to rewrite 1/3 to also be a base of 3, okay? So I'm going to rewrite 1/3 to actually be 3 to negative 1, and then it's raised to x minus 1, okay? These mean the same thing. And then we're going to rewrite 27 to be 3 cubed, okay? So it's going to equal 3 cubed. So we first want to multiply our exponents together. So I'm going to have 3, and then negative 1 times x would be a negative x, and negative 1 times negative 1 would be a positive 1, equals 3 cubed. Same base now, so I can drop the base and work on just exponents. So I'm going to have a negative x plus 1 equals 3, minus 1 on both sides. So I get negative x equals 2. Divide both sides by negative 1 just to cancel out those negatives. And now you have a positive x equals a negative 2. All right, last couple examples. Just another simple one for us. So we can rewrite 4 to have a base of 2. So I'm going to leave my 2 to the power of x. And then I'm going to rewrite 4 to be 2 squared. Okay, and then we've got to multiply our exponents. So we get 2 to the x equals 2 times, well, I'll leave my base, and then 2 times x is 2x, and 2 times 6 is 12. So we're going to drop our bases. So I'm going to have x equals 2x plus 12. So I want to get my x's on the same side. I'm going to do a minus 2x on both sides. X minus 2x would leave me a negative x equals 12. And once again, divide both sides by a negative 1. And you get x equals a, oops, I almost forgot. X equals a negative 12. Okay. And then this one down here, we have 25 and 125. Okay, so, well, 1/125, but we know we need to use a negative exponent here to flip that. Okay, but what I want to see is, well, 25 squared, it doesn't give you 125. So 25 is not the common base. The common base for these two numbers is going to be 5. Okay, you know this because 5 squared is 25, and 5 cubed is 125. So 5 is the common base that will give me both of these two numbers. Okay. So I'm going to rewrite 25 to be 5 squared, and I'm going to rewrite 120, well, sorry. I'm going to rewrite 1/125 to be 5 to the negative 1/3. Negative third. So 5, let's just show you, raised to negative 3 gives us 0.008, right? Same thing if I did 1 divided by 125. It gives you the same decimal. These two things mean the same, okay? So we're rewriting 1/125 to be 5 to the negative third. So here we're going to have 5 squared is a negative 3x plus 3 equals 5 to the negative 3 raised to x plus 1. We're going to multiply our exponents, so I get 5. 2 times negative 3x is a negative 6x. 2 times 3 is 6. And then 5 to the negative 3 times x is a negative 3x. Negative 3 times 1 is a negative 3. Same base, so I can drop my base, and I just have negative 6x plus 6 equals a negative 3x minus 3. Okay? It doesn't matter which x you choose to cancel out first. I'll do plus 3x on both sides. And we get a negative 3x plus 6 equals a negative 3. Minus 6 from both sides, so we now have a negative 3x equals a negative 9. Divide both sides by negative 3, and we get x equals negative and a negative, make that a positive 3. Oops, and you can't see. Divided both sides by negative 3, and we got x equals a positive 3.